2016 linear motion question 1A. A car with initial speed u meters per second, constant acceleration for 4 seconds, travels 40 meters while accelerating, then moves with uniform speed and travels 45 meters in 3 seconds. That will enable us to get v. They then brought to rest with constant retardation 2f. Draw a speed time graph for the motion. Okay, we start with the speed time graph. So he's not starting from rest, he's starting from a speed here of u, or she, up to a speed of, let's call it v, 3 seconds along here. We just have our time down the bottom. So it's a speed time graph, our speed is always on the left, and our time down the bottom. Moves with, what are we told, for 3 seconds, 45 meters in 3 seconds. So it has to be 15 meters per second. And then constant retardation 2f. And we're actually told as well, I didn't write it, constant acceleration f. Going up this way. Okay, so we have a couple of things different going on here. We can get v, let's add v to our distance or to our speed time graph. 45 meters in 3 seconds. Well, that's going to give us 15 meters per second. So v is 15. Part 2, we're asked to find u. So let's fill some information here. 4 seconds was the initial. This was 3. We call this one t. We'll need that in a minute. So if this is 15 from here to here, if we call this one, well, this one is u. We have u from here to here. So this is going to be 15 minus u. And they tell us 40 meters was traveled in this time. So it's the area of the two shapes is equal to 40. So we have 4 times u plus half the base by the height. Half the base is 4 and the height is 15 minus u. Has to be equal to 40. So 4u, and we have, this is going to give us a 2. So we have 2 by 15 plus 30, and 2 by minus u equals 40. So we're going to get 2u is equal to 10. So u is 5 meters per second. 5 ms to the minus 1, or m/s, whatever way you choose to write it. So that's u, we've got as 5. And part 3, the total distance traveled. So let's have a look at the total distance traveled. So we're really just focusing on this one. We have 45 in here already, and we have, what do we were told 40 for this one. So it's the last triangle. We need to find f. So what have we got in the last triangle? We have v is 15, comes to rest, u is 0, a is equal to 2f, and we don't have any other variable there. We don't have time, so we're going to need to go to the first triangle. We'll pause that for a second. We'll go to the first triangle where u was 5, v was 15, t was equal to 4 seconds here. So we can use v is equal to u plus at to find a was equal to f to find f. So v is equal to u plus at. 15 is equal to 5 plus 4f. So we have 10 equals 4f. So f is going to be equal to 2.5. So over here 2f is equal to 5. It's going to be minus 5, it's slowing down. 2f is equal to minus 5. So if we get, clearly see we can get how long it's going to take to get from here to here. It's traveling at 15 up here, and it's going to go to 0, and it's going down at 5 ms to the minus 2. So we can see t is going to be equal to 3. T is equal to 3. So v is equal to u plus at. That's where we're going to get this t from. That's 3, but we've already seen that. But if we want to just fill that in just to be doubly sure, 15 is equal to 0 minus 5t. So you can see that the 0 and the 15 in the wrong place. My V is 0 and my U is 15. So we can see there that's where the T is equal to 3 is coming from. And to get the distance for that final triangle, it's going to be half the base, which is 3, by the height, which is 15. So what's that going to give me? Half of 45, 22.5 meters. We're going to add on 40 in the first sector and 45 in the second one. That's going to give me 85 plus 22.5, which is 107.5 meters.